continue with our discussion about properties of continuous time Fourier transform. The fourth one is time reversal property. According to this property, if x of t has a Fourier transform capital X function of j omega, and now if you introduce time reversal, it means x of t become x of minus t, then the Fourier transform will become x of minus j. So this is something which you can easily prove. So I will leave this for you to prove how you can prove this thing, that time reversal has this. Let's move on to fifth property. Time scaling property. So according to this property, x of t, and then time scaling means x of t becomes x of a t, where a is some constant. According to this property, the Fourier transform of this time scaled signal it will be equal to 1 divided by absolute value of a into x of j omega divided by. Now, let me prove this property, because I think maybe some students find it difficult to prove this. So what is going to be the result? It very much depends upon what is the value of this constant. So we can say that this a can be positive, or this a can be negative as well. So let me prove this for positive case, and then we can generalize this result for the negative case, and finally we will get to this result. So let's assume that x a of t let's assume that its Fourier transform is x dash j, and we will find out what is this value. Our result should be this. So making use of the general result, if I am going to find out the Fourier transform of this signal x a of t, so I will multiply this with e power minus j omega t, and then I will integrate it from minus infinity to plus infinity, and this will give me the Fourier transform of this time scale signal. Now let me replace this at by a new variable tau, so that dt becomes equal to d tau by a, and t becomes equal to tau. So limits with respect to t are minus infinity to plus infinity, and because of this direct relationship between t and tau, if t is minus infinity, tau will also be minus infinity. If t is plus infinity, it will also be plus infinity. So the limits will remain the same. So we get x of tau e power minus j omega. In place of t, we get tau by a, and in place of dt, we get d tau by a. Okay. This a is a constant. So we can take it outside of the integration. So 1 over a minus infinity to plus infinity x of tau e power minus j omega by a tau d of t. Now, if you look at this particular integral, it's obvious that it is the Fourier transform of this signal with respect to omega by a. So what is this thing? This is actually Fourier transform for this value of omega. And then you have 1 over a. So x dash j omega is equal to this. This is the result when we consider that a is positive, when this number is positive. If you now practice it in the same manner, but assume that a is some kind of a negative number. So you will have x of minus 8. And then do this, what you will get is, you will get the same answer as I got over. So based on that, you can see that we have this absolute value. So no matter whether a is positive or negative, we will get a positive value over a. Okay, but this value, of course, inside this you will have minus. So this is for positive. For negative, so if a is negative, then what you will get, its Fourier transform will be 1 over a x of minus m. You can see that we have proved this property. This is the effect of time scaling. And you can see another important conclusion based on this time scaling property. You know about time scaling that this, what is the effect of time scaling on the signal, or signal can get compressed or it can expand. But its effect on frequency domain is inverse. So if you increase a over here, this thing will decrease. So it means if you compress the signal in time domain, it will expand in the frequency domain. If you expand the signal in time domain, it will get contract, or it will get compressed in frequency domain. And we have already developed this inverse relationship between time domain and frequency domain. So this is the same behavior that we have already discussed by when I was solving example number 5 in our first or second session. Let's move on to the next property, property number 6. And that is frequency shifting. So rather than time shifting, now we are talking about frequency shifting. X of t having Fourier transform of x of j omega. If we introduce frequency shifting, so it means, let's say this omega becomes omega minus omega. Use another set of brackets. So let's say you have something like this. So this is frequency shifting. Our signal from omega has moved from omega to omega minus omega naught. So what will happen to the signal in time domain? Let me write this property. X of t will get multiplied with x of t plus j omega naught. So what is the effect of frequency shifting on the time domain signal? Time domain signal gets multiplied with this. Let's look at the proof of this. So let's assume that this is our signal for which we want to find out what is the Fourier transform of this signal, and let's call it x of dash. So x dash j omega is the Fourier transform of this signal. So if I want to find the Fourier transform of this signal, what I will do? I will take this signal e j omega naught t x of t and e power minus j omega. This is how we calculate the Fourier transform of any signal. This is our signal. So this is the factor that is multiplied and then we integrate. So this can be represented as x of t, and then I can represent it as e power j I will say minus omega minus omega naught. Now, if you look at this expression on the right hand side, it is Fourier transform evaluated at this frequency. तो इसको हम किससे replace करेंगे? ये क्या चीज है? This is x of j evaluated at omega minus omega. So we have proved कि अगर टाइम डोमेन में इस तरह का सिग्नल हो उसका Fourier transform. So this is frequency shifting property. Any question? Someone has raised hand. Let's move on to seventh property. Differentiation in time domain. In time domain. So if x of t has a Fourier transform pair capital X, and now if you perform a derivative in time domain, so what is going to be the Fourier transform of this signal, which is now the derivative of the original signal? According to this property, it will be equal to j omega into the original Fourier transform. So what is the proof of this property? To prove this property, I will make use of the inverse Fourier transform relationship. So x of t is equal to 1 over 2 pi or I can also use, as again, these properties can be proved either using Fourier transform relationship or inverse Fourier transform relationship. It's up to you, whichever you find convenient. Okay. So let me use this one. इसी को use करते हैं so that you get an idea कि ज़्यादातर मैं properties इस equation को use कर रहा हूँ जिसमें हम Fourier transform use कर रहे हैं. ठीक है. So we are using this property. So most of the properties are proved based on this forward Fourier transform. अब हम inverse Fourier transform की मदद से देखते हैं कि कैसे prove कर सकते हैं. So this is the equation, which is also known as synthesis equation. So let's take the derivative on both sides. अगर हम इस standard equation को भी देख लें पहले, according to the structure of this equation, this term is the Fourier transform of the term on the left hand side. 1 over 2 pi e power j omega t, these are the constant, or you can say the standard structure of the equation. Okay. Whatever is written beside this thing is the Fourier transform of the signal which is on the left hand side. Okay. Based on that, अब अगर हम इसका derivative लेते हैं, so let's take the derivative on the left hand side with respect to time, और इस तरीके से right hand side पे भी हमें लेना पड़ेगा. So जो term time पे depend करती है वो आपके पास ये वाली term e j omega t. All we need to do is find out this thing. So derivative of e j omega t will be j omega into e j omega t. So what we get? We have derivative. Then we have 1 over 2 pi minus infinity to plus infinity x of j omega. And then we have j omega e j omega t d. Now if you go back to मैंने statement दी थी, this is the Fourier transform of this. Now you will see, let me change the color, this must be the Fourier transform of this thing. So if you look at the property, what is the effect of derivative? It is j omega into x of j omega, right in front of you. Now, before I talk about the last 1 or 2 properties for today's lecture, let me share the attendance link. Just give me 1 minute. Okay, attendance link मैंने आपके साथ share कर दी है chat window में, so you can start marking your attendance for today's lecture. Now this was property number 7, that is differentiation and time domain. Let's talk about property number 8, that is differentiation in frequency domain. So according to this property, if you perform differentiation in frequency domain, it means if you take the derivative of capital X, which is function of omega, and then you multiply it with this j, this is going to have an effect that x of t is going to be multiplied with t. Again, you can shift this term over here, but usually we place j over here. So if you look on this right hand side, what we are doing, we are performing differentiation in frequency domain. So if we are given the Fourier transform of some signal, and if we take the derivative of that signal, so what is the corresponding effect on the signal in time domain? This time domain signal get multiplied with t. So if you want to prove this property, So how you will prove it? So for this, let me use the analysis equation of Fourier transform, also known as Fourier transform equation. So this is the signal and this is the Fourier transform. But right now we are interested in taking the derivative of this function with respect to omega. So I will take the derivative of this equation with respect to omega on left side as well as right side. So derivative of Fourier transform. On the right hand side, this x of t is not function of omega. It means all we need to do is take the derivative of this. So this is something which you can easily find. So what you will get? You will get minus infinity to plus infinity x of t. You get minus j omega e power minus j omega t d. Sorry, not minus j omega. It should be minus jt. So all of you are sleeping. No one is pointing out the mistake I am making. You people are here only for attendance. As many students were sending me messages on chat, sir, attendance link share kar dein. The only thing that is important for you in any lecture is attendance.
No सर हम अटेंडेंस मार्क कर रही थी तो आपका स्क्रीन हमसे गया था
अच्छा चलें जी, चलें मैं आपको शक का फायदा दे देता हूँ. ठीक है, चलें. ओके, सो नाउ इफ यू लुक स्ट्रक्चर को देखें, ये सिग्नल था और ये इसका फोरियर ट्रांसफॉर्म. इस इक्वेशन को देख के हम ये कहेंगे कि ये सिग्नल है जिसका फोरियर ट्रांसफॉर्म. सो ये जो मैं यहाँ पे इसको लिख लेता हूँ. सो वी विल से कि माइनस जे टी एक्स ऑफ टी का फोरियर ट्रांसफॉर्म पेयर क्या है? डेरिवेटिव विद रिस्पेक्ट टू ओमेगा. बट इफ यू लुक, जो मैंने प्रॉपर्टी लिखी थी, मैंने तभी आपको कहा था कि ये जे टर्म आपको, मैंने इसको यहाँ पे शिफ्ट किया हुआ है. ठीक है, तो अगर आप इसको देखें, यहाँ पे ये माइनस जे है, इस जे को आप यहाँ पे अगर देखें, तो इट मीन्स दिस इज द प्रॉपर्टी जो मैंने प्रूव करनी थी. डिफरेंशिएशन एंड फ्रीक्वेंसी प्रॉपर्टी का मतलब क्या है कि डेरिवेटिव ऑफ फोरियर ट्रांसफॉर्म एंड दिस फैक्टर आपको टाइम डोमेन को टी के साथ मल्टीप्लाई करना पड़ेगा. अच्छा, इसको यहाँ पे एक और चीज मैं यहाँ पे शो की है या नहीं शो की, लेट गो बैक. डिफरेंशिएशन टाइम, यस, ये मैंने जो प्रॉपर्टी प्रूव की है, ये मैंने फर्स्ट डेरिवेटिव के लिए की है. ठीक है, अगर आप टाइम डोमेन सिग्नल का फर्स्ट डेरिवेटिव लें तो उसका फोरियर ट्रांसफॉर्म, लेकिन इसको हम जनरलाइज कर दें, मे बी हमें सेकंड डेरिवेटिव लेना हो, थर्ड डेरिवेटिव लेना हो, तो फिर क्या हो? इसको हम जनरलाइज तरह करेंगे कि वी विल से कि अगर nth डेरिवेटिव हम लें, इसका इफेक्ट क्या होगा? j ओमेगा रेज़ टू पावर n into x of j. तो ये मैंने इसको आपके सामने जनरलाइज कर. तो अब आप इस प्रॉपर्टी को फर्स्ट डेरिवेटिव, सेकंड डेरिवेटिव, थर्ड डेरिवेटिव हर एक के लिए यूज कर सकते हैं. सिमिलर, ये जो प्रॉपर्टी आपको मैं शो कर रहा हूँ, ये आप देख रहे हैं कि आप इस फंक्शन का फर्स्ट डेरिवेटिव ले रहे हैं. अगर आप इसका nth डेरिवेटिव लेंगे, तो मैं अब इसको जनरलाइज कर रहा हूँ. ठीक है, इसी इक्वेशन में मैं इसको जनरलाइज कर रहा हूँ. अगर हम इसका nth डेरिवेटिव लें, इसका इफेक्ट क्या होगा? j रेज़ टू पावर n हो जाएगा और यहाँ पे t रेज़ टू पावर n हो जाएगा. तो ये मैंने आपके सामने इसको जनरलाइज कर. So now you can use it for any other derivative, whether in frequency domain or whether in time domain, आप इसको use कर सकते हैं. I think it's enough for today. आज के लिए इतना बहुत है. We will continue. कुछ और properties भी रह गई हैं, वो हम फिर next lecture में cover करेंगे. So